All right, so in this video, we're going to look at a few more examples with higher order functions, and we're going to look at more specifically at function values. So let's just try to create a function called apply to now. So I'm going to create a function apply to, and a little bit for me, at least in the math side of things, this function apply to would look like a function that takes in three parameters. So it takes in a function takes in three parameters, and the three parameters are the first parameter is some kind of function f. The second parameter is let's say some integer or some kind of some value x there, and the third could be again some kind of an integer value y there. And the definition for apply to is basically it just returns back the value of f of x comma y. Okay, so this is how you would typically have this in math, right? So apply to is a function. In this case, at least looks like a function of three variables, and the first variable is a function, second is an integer, third is an integer, and the return value is again some kind of an integer. Now again, of course, I'm assuming here that this f over here is a function, because a function it also has some kind of functional type, and the functional type for f here, the functional type for f over here is basically it goes from an integer to an integer and returns back to you another integer. Okay, and so this is what kind of assumption I'm making here. And of course, f doesn't need to be taking an integer, but let's just kind of simplify this problem a little bit so that we kind of get an intuition feel for what's happening. And so what would the functional type for apply to look like? Well, apply to here, a function, it's just a name, it's just a function name, and the type for this is basically the first type over here is an f there, and I've already said this is what f looks like. This is what f looks like. So the first parameter is basically a function that goes from an integer to an integer to an integer. This is what basically f is. The second parameter is an x here, so I'm going to assume this x, whatever this x is going to be, again, some kind of an integer. The third parameter over here is an integer as well. And what apply to does, it consumes these parameters, and gives you back some kind of an integer. Okay, let's just try this out. So first thing, let's just get rid of these things from last video, and we'll say let apply to take in f x y, and it's going to give you back a return value of whatever is x, f of x y. And let's just run this. And of course, over here, the very first time when I run this, there are no constraints on this x and y. So what F# is doing, at least inference engine is doing, is going to give you some kind of a functional type that is very, very, very general there. Okay, so it tells you that in this case, the type for f is basically a function that goes from an a to a b to a c. And of course, in the last just moments ago, we inferred a, b, and c to be an integer. And likewise, the second parameter, which is an x over here, that gets into apply to, is some value of type prime a, but we're going to assume it's going to be an integer as well. And the third parameter is, in this case, going to be an integer as well. It all gets consumed by the function apply to, eventually giving you back some value, which happens to be, in this case, prime c, but we're going to assume it's going to be, again, some kind of a value of type integer. Okay, now let's just create another function. Let's just create a function called, in this case, multiply, that takes in x, y, and returns back simply a multiplication of x times y. Okay, we're going to run this, and I can see that multiply over here has been inferred as a function that just takes in two parameters, x and y, and gives you back some value that happens to be an integer. Now what I'm going to do is I'm just going to go back to the first definition of apply to. So I'm going to say let g equals to apply to, and I'm going to first pass it. And what I'm going to do is I'm going to use function curring here. So just to understand what I'm doing at this time, and I'm going to say apply to. So let's go back to apply to. This is what apply to looks like. This is the actual functional type of apply to. Okay, so this is the functional type apply to. And if I would apply function curring on this, this is going to look like, just to put parentheses here, that's the order of my parentheses there. So the first parameter is this function, which in turn gives you back a function that goes, in this case, from a prime a to a prime B, giving you a prime C. So let's do that. So I'm going to say apply to. I'm going to say in this case apply to, and I'm going to just partially apply this by passing in this case multiply. So multiply. Okay, and what it means is that the G over here is going to have some kind of functional type where it's going to be basically going from an integer to an integer to an integer. This is what G is going to look like. All right, so this is what I'm inferring G to be. Okay, and let's see whether F sharp gives me that correctly by partially apply to with the first parameter. So if I say apply to and I pass in multiply, if I run this, I'm going to see that the type for G is basically a function that goes from integer to integer, giving back an integer return value. So far so good. And finally I'm going to say let value equals to whatever is this G, and we pass in, let's say G requires 2 integers. Okay, or I can say again partially apply G, so I say G of 10, and which in turn means that if I partially apply G, I'm passing in 10, the type over here is basically, if I pass in this 10 there, it gives you back another function that goes from an integer to an integer. So value in this case is basically a function. It's a function that goes from an integer to an integer. Okay, so let's just run this again. And I can see a value in this case is basically a function that goes from integer to integer. And then finally I can say let value. I know, really bad names here, but I'm just trying to get the point that now when I say value of, let's say 20, what am I going to get here? Is this going to be a multiplication of 10 and 20? So that's going to give you 200. And this is basically finally value that's going to give you back a value of 200. Okay, so I hope you found this a little bit useful and playing with this kind of these silly examples, but again, kind of driving the force, kind of driving the idea that we can do a lot of function, a lot of code reusing by using function composition. And oh, sorry, I've not even touched on function composition yet. I'm going to do that in my next video. But what we've done here is looked at an example of function of code reuse by partially applying functions, but at the same time tying this up with some of the higher order function idea of passing functions as a parameter. In the next video, actually the next two videos, we're going to look at lambda expressions, and we're going to look at function composition and pipelining.